Good afternoon, students. Students, good afternoon.
Good afternoon, ma'am.
Okay. Have you remembered queuing theory formulas? Go through the third problem. Students, Thursday I will take test. Remember, Thursday morning at your respective timings, class timings, at your respective class timings, I will take the test. But a small modification in that is 5 questions consists of 2 marks. Another 3 questions consists of 5 marks. Actually, I wrote 15 questions consists of 2 marks each. 15 twos are 30. Not like that. It's of 25 minutes. 25 marks. Have you prepared thoroughly? Go through the third problem, students. Go through the third problem. Go through the third problem and try to solve. Solve it, you know how to solve. Clearly, they have mentioned arrival rate is given in terms of hour, service rate is given in terms of hour. Then you know average time for which a machine will be kept in the repair shop. Shop is the server. That means what is first bit? Lambda is given 4 per hour. Solve it, first question. Remember the formulas. Arrival rate is always represented by the letter lambda. Service rate is always represented by the letter mu. If the server is busy, that is represented by rho, lambda upon mu. If there are no customers at the system, that is rho naught, that means the server is idle. The formula is 1 minus lambda upon mu. Then LS LQ, that is queue length, or you can say average number of customers waiting in the queue, that is LQ. Okay, before writing LQ, I told LS we will write length of the system, lambda by lambda upon mu minus lambda. Length of the queue, what is the formula? Lambda square upon mu into mu minus lambda. Similarly, waiting time at the system, that is WS, the formula is 1 upon mu minus lambda. Then WQ, lambda by mu into mu minus lambda. These formulas you should remember. Correct? Then another formula what I told, there are k customers. Correct? Probability of n greater than or equal to k is there. Only these formulas. Among these 6, any 4 will come. Okay, right now solve it, students. Right now you know the formulas. First one is average time for which the machine is kept in the repair shop. That is, first bit is WS. Here what is given? Lambda is given, mu is given. What is lambda? Lambda is 4 per hour. What is mu? Service rate is given. Last sentence, if you go through the last sentence, 6 per hour. The first question, average time for which the machine will be kept in the repair shop. That means the first bit is WS. What is the formula? 1 upon mu minus lambda. That is 1 upon 6 minus 4. That is half an hour. That means 30 minutes. Go for second one, students. Go for second one. What proportion of his time is the repairman expected to be idle? That means what is the formula? Rho naught. Rho naught, what is second bit? Second bit is rho naught. Rho naught is equal to 1 minus lambda upon mu. That is 1 minus 4 upon 6. 2 2s are 2 3s are, that is 1 by 3. Here, what does it mean? There are no machines in the repair shop. That is system. Tell me the third one. Probability that there are 3 machines in the repair shop. Go through the formulas. There are 3 machines. What is the formula? Go through the formulas and then do it. Exactly, n customers in the system. स्टूडेंट्स आप लोग सॉल्व कर रहे हैं ना? आशीष, आशीष,
यस मैम,
सॉल्व कर रहे हैं ना आप लोग?
यस मैम.
हाँ. Tell me the answer, third one.
And 0.0987.
Okay, okay, whatever it is, I will check.
1/9.
Okay, 0. That's all. 0.099. Okay. Third one. Who have completed third one? Go through fourth one. Lakshmikant, which formula have you applied for third one? Lakshmikant. (306) marketing. Lakshmikant.
Hello, ma'am.
Lakshmikant, which formula have you applied? What bit?
मैम अभी हमने जो यूज किया था ना मैम 1 माइनस लैम्डा म्यू, तो उसकी जगह पे ये प्रोबेबिलिटी ये है ना मैम, रो 0 इन ब्रैकेट लैम्डा म्यू अपॉन इन होल ब्रैकेट n.
Okay.
बराबर मैम?
Very good, very good. Correct. Everybody apply the same formula. Fourth one. What is fourth one answer? Here, one modification for fourth one. Here, if you see carefully, what they asked, probability that there are two machines. There are two machines in the waiting line. That means this formula you have to apply. There are two machines in the, that is probability of n greater than or equal to 2. What does it mean? Lambda by mu whole square. What is fourth bit answer? Everybody is having calculators, I hope.
Ma'am, the fourth one, wouldn't it be the length of the cube?
Pardon me, Saurabh?
The fourth one, ma'am, the formula will be for the length of the cube, no?
No, here what they asked, probability that there are two machines, no?
Yes.
Probability that there are two machines in the waiting line. Probability that there are two machines and is greater than or equal to 2.
Yes, ma'am.
Fourth question is, third question का क्या लिखा है आप लोग बता दीजिए. Third question, what formula have you applied? Ashish, tell me the formula. Third question, what you wrote?
Lambda upon mu raised to n into 1 minus lambda upon mu.
Very good. Fourth question, what you have to write? Fourth question is probability that there are two machines. There are two and is greater than or equal to 2. What does it mean? P to the power of rho to the power of 2. That means lambda by mu whole square. That is 4/6 whole square. Shivaji, are you getting the answers? Pavan Shivaji, 307. Sajal, are you getting the answers?
Yes, ma'am.
Okay, very good. Everybody completed this? Any queries related to third problem? Based on
Ma'am?
formulas only.
Ma'am, how we distinguish between the machines are in system and in line?
Ashish, means voice is breaking. Ashish, can you ask me again? Slowly, little bit slowly.
Yes, ma'am. Ma'am, how we distinguish between these repair shop and waiting line?
Okay. How to differentiate between whether it is in queue, whether it is in server, whether it is means what formula, probability of n greater than or equal to k, when to apply. You are asking that only, right?
Yes, ma'am.
Okay. Here directly they asked probability. They have not asked probability that there are two machines in the waiting line. They asked probabilities only. Here they didn't mention the length of the queue as well as length of the system. Ashish, clear?
No, ma'am.
Here, probability that there are two machines in the waiting line. That means here directly they ask the probability. This sentence is not talking about length of the queue as well as average waiting time of the queue. ये सेंटेंस में से हम लोगों का एवरेज वेटिंग टाइम ऐसा कुछ मीनिंग आ रहा है क्या?
No, ma'am.
That's why it is probability only. Clear, Ashish?
But ma'am, when we take these two formulas, na, that probability of exactly n customers in the system and probability of k or more customers in the system.
We will go through the formulas. I will
that,
explain. Wait, Ashish. We are going through the formulas. Here, probability of exactly n customers in the system. It talks about system. Probability of k or more customers in the system. Here, the difference is here exactly n customers. That means 5 customers are waiting. Exactly 5 customers are waiting. Then we will take this formula. P5 is equal to rho to the power of n into 1 minus p. That means rho to the power of 5 into 1 minus rho we will take. Here probability of k or more customers in the system means you are including that customer. Understood?
Yes. But ma'am, these are considered for system. How we can count it in queue?
How we have considered if they are in queue means see they are waiting for service. That means whenever the service is given, then only the customer will departure in these two cases. The fourth element is departure. That means k or more customers in the system. That means they will take the service and then only they will leave. That is the meaning of these two formulas. They cannot be impatient customers. They can be patient customers. In these two cases, we will consider the patient customers only. Stay in the queue till being served. Clear?
Yes, ma'am.
Ma'am, is it so that that P of probability of n greater than or equal to k is for the queuing or the waiting line only? Because I think that's why we have taken it here.
Again, ask Saurabh.
Is probability of n greater than or equal to k is the formula for the waiting line in general, or yes, ma'am. In general, it is taken for the waiting line, or actually, I'm also confused in
There
that.
are more customers in the system. Probability of k or more customers in the system. These two cases talks about only system related only. Why? These two formulas belonging to patient customers only. They cannot leave the queue in between. These two formulas are derived for patient customers only. That means still being served, they will be in the queue. That is the meaning of these two formulas.
My question was that we have taken P of n formula for the 3 machines in repair shop. and P of n greater than or equal to K for the waiting line. So do we have to differentiate like that only?
You can differentiate like that.
So ma'am, what if we take 3 machines in repair shop, the formula of P n of n is greater than or equal to K in that scene?
You are talking about which question, which one, third one or fourth one you are talking about right now?
I mean third one. Ma'am, because in both the questions we have taken 3 machines and 2 machines. There is nothing like 2 machines or more like that. So there is a fixed number they have given to us. So can we take in the third question the formula that we have taken in the fourth question?
Third one is different. In the repair shop, that means it is system, it is showing here probability that there are more than 2 machines in the waiting line. That means they are still in queue. That's why we will take probability of n greater than 2.
Sir, please.
Okay, ma'am.
Ma'am, ma'am, in the statement, in the system that counts the people who are currently going to be served and those who are waiting in queue, na?
Only one repairman who provides the service on contract. The cost of non-productive machine, this is extra information given. That is not included in our syllabus. One more question is there. We need to find out total cost per hour like that. For that purpose, they have given extra information that is not required for us. If you see the syllabus of queuing theory, what they mentioned, single queue, single server, numericals are expected, but not multiple queues and multiple servers. एक बार syllabus देख लो आप लोग. Syllabus copy है तो syllabus देख लो. This is additional information they have given. आशीष.
Yes, ma'am.
वही पूछे ना आप?
Actually, ma'am, that statement is making confuses because it is saying that we have to find the customers who are waiting in queue, and here we are using the formula that the customers are in the system. So in the system counts like the customers which are waiting in a queue and the customers which are being served.
Fourth question is, listen carefully. Fourth question and third question, I will differentiate the third and fourth. Here, probability that there are 3 machines in the repair shop. That means the repair shop is considered as a system server. That's why we have applied this formula. Fourth one is probability that there are more than 2 machines in the waiting line. In the waiting line, still they are in queue. Later they are being served. That is n greater than or equal to, n is equal to 2 here, the given problem. That means rho to the power of 2. They are still in queue but not being served at. That's why they asked that.
But ma'am, when we use this formula, then in system counts for the customer which is being served and the customer which are waiting.
Ashish.
So we have to.
Ashish, I will tell you the difference. Listen. These two formulas are meant for system. Okay? Whenever you are considering system, you have to consider waiting time plus being served time. Both times. Whenever you are considering system, both the times you have to consider. But here, the fourth question, whatever the question I asked, that is probability that there are 2 machines in the waiting line. That means they are waiting in queue but not being served yet. That is the meaning.
Yes, ma'am.
We will solve more number of problems, then your queries will be resolved.
Okay, ma'am.
Any query till now? Here, instead of that,
No, ma'am.
instead of that, I will tell you. 1 second, wait. Here, what I asked? Here, I asked waiting line. Okay, if I ask directly in the repair shop, means here n is equal to 3. Here, n is equal to 2. Here, I asked waiting line. That means they have not been served yet. We are considering the queue time only. Then go through the fourth problem. Students, right now go through the fourth problem. What is mu for fourth problem, students?
Forty-eight.
Mu 14.
48 minutes.
Okay, okay. You have converted in terms of minutes. Okay, one is given in terms of hours. Okay. Anyway, you can do it. Here, mean arrival rate is given. Lambda is given 10 sets. They have given 10 sets per 8-hour day. Sets per 8-hour day. Then here, mu is given in terms of minutes. That's why better to convert in terms of hours. Mu is how we will convert. It is given as 30 minutes. That's why 60 upon 30 actually in general to cure. But the condition is given as 8 hours per day. That's why you have to multiply 8 into 60 upon 30. 8 into 60 upon 30, then 16 sets. In the final examination, you have to verify what I told. The condition should be strictly lambda is less than mu, then only you can form a Q, otherwise Q cannot be formed. 10 sets is less than 16 sets? Yes. Right now, you can solve first and second bits easily. Saurav, it is correct only. You want to keep in terms of minutes, you can solve it, don't worry.
Okay, ma'am.
First bit is, what is the repairman's expected idle time each day? Understood, students? Arrival rate is given as 10 sets, but the consideration in day 8 hours they were considering. That's why you have to write in the final examination 10 sets per 8-hour day. Mu is given in terms of minutes. That's why you want to convert in terms of hours. That's why 60 upon 30, but 8 hours per day is given. That's why you have to multiply with 8. 16 sets. Verify in the final examination whether this lambda is strictly less than mu. Yes. Then what they asked, probability that the repairman is idle. What does it mean? That is rho naught. First bit is nothing but rho naught. You know the formula. What is rho naught's formula? 1 minus lambda upon mu. That is 1 minus 10 upon 16. 6 upon 16. You want to keep 6 upon 16, it's okay. Otherwise, 2 3s are 2 8s are 3 upon 8. Next, what they asked, here what 3 upon 8 we got. Here, what is the repairman's expected idle time? Each day they asked, each day. That means what we have to write? We have to write idle time per day. We have to find out repairman's idle time per day. That is rho naught into number of hours working per day. That is how many hours? 8 hours. 3 upon 8 into 8. Finally, we will get 3 hours. Per day, among 8 hours he works. Among 8 hours, how many hours he is free? 3 hours. The answer is 3 hours. Solve it. Second question. Find the average number of sets ahead of a new arrival set. That is nothing but average number of sets. Okay, ahead. That means still they are in queue. That means the second bit answer is queue length. The second bit answer is queue length. Find average number. If you see average number of customers in the system, average number of customers in the queue, your average number of sets ahead of a new arrival of sets. That means still they are in queue. That's why average number of sets, that is length of the queue. The second bit formula is LQ. You know the formula. LQ is equal to lambda square upon mu into mu minus lambda. Substitute the values and tell me the answer, students.
One.
Very good. 1.042, you have to round it off. 1 set. Very good. Remaining students also try it out. The answer is 1.042. Round it off, then you will get 1. Who have completed that problem, then go through the 5th problem. Everybody got the answer? Vaishnavi?
Yes, ma'am.
Nikhil got the answer?
Yes, ma'am.
Okay. Then go through the fifth problem. Here, if you see, this problem has come in 2013. Whenever means 2013 pattern, most of the students answered this way. That time my MBA, 17,000 students were there that time. Total strength in the year 2013, 17,000. May 2013, the question paper pattern. May 2013, this question has come. But most of the students, what they wrote, I'm writing here. Lambda is given. If you read the sentences carefully, one customer arrives for cashing the check, that is 15 minutes. One customer arrives, that means arrival rate is 15 minutes. The second one is payment counter takes, for serving the customer, it is given as 10 minutes. Mu is equal to 10 minutes. Most of the students' answer is this. Lambda is not less than mu, correct? 15 is not less than 10. 15 is greater than 10. Most of the students wrote lambda is not less than mu. The given question is wrong. This is the answer they have given in the final examination. But here, mean arrival rate of customer, if it is given in minutes, we will check it for hours. How to check it for hours? Lambda is equal to 60 upon 15 minutes. Then it is 4 customers per hour. Similarly, mu, that is 60 upon 10.